Hi guys, this is Mrs. Hasten. I am based at IHS, but like all of us, we've got students from all around the district. Anyway, I am going to be working through the lesson 2.1, the second part. How many pairs of shoes do you own? So how many pairs of shoes do students own? Y'all answered this question for us on the Google form, but it says, let's use students in this classroom as a sample of all students. So in a normal year, we might have 30 people in a class. So I actually randomly selected 30 of our data points and put them here. Let me show you how I did that really quickly. So I took our responses. And I copied that whole column. I think we're up to 522 or something. Yeah, responses so far in this Google form now. And so I put them over into a new spreadsheet so I could play with it a little bit. What I did was I Googled how to randomly select 30 numbers. And what came up was that I was supposed to use this RAND feature. So you don't need to know how to do this, but I just thought it was interesting. So I randomly assign numbers to all of the numbers here, and then I sorted the sheet by that column, and so it randomly sorted, and then I took the top 30 there. So we could simulate maybe having one class. Well, that's not what I wanted. This is what I wanted. So we could simulate having one class of data. So this would be a good time to pause the recording and copy these numbers down. Okay, so hopefully you paused it and you have the numbers copied down. So the next question is number of pairs of shoes categorical or quantitative? One question I ask myself is, could the responses be averaged together? And if they could, it's usually quantitative. Or if taking an average would make sense. So would it make sense for us to take an average of the numbers of shoes that people have? Well, yeah, it would. So that makes this quantitative. Okay, it would make sense to take an average. Our responses are numerical. Your teacher might have already gone over this example, but there's like a very classic example of a numerical response that's not actually not quantitative, it's categorical, and that would be zip codes. There's not necessarily a rhyme or reason to how they're assigned, and you would never have several people tell you their zip codes and then average them together. That would make zero sense. So that's an example of a numerical response that's actually categorical. But in general, numerical responses are quantitative. All right, so now we are going to create a stem plot. I already put the data in order for us from least to greatest, and that's how you're going to want to start. If you started with some raw data, you definitely want to sort that sheet to get the data in order. All right, we need to always have a label. So, wow. Number of pairs of shoes. All right. The stem and leaf plot, or stem plot, the stem is on the left and the leaves are on the right. So we need to figure out how many digits these numbers have. So our first numbers have one digit. We could make them have two digits by just putting a 0 in front. And then all of our numbers here would have equal numbers of digits. And that's what we need, okay? Because otherwise you wouldn't be able to tell the difference between a 3 and an 8 versus a 38. So we're going to have all of our single digit numbers are going to have a 0 in front of them. So if we wanted to set up our leaves here, we've got a tens place of 0, a tens place of 1, a tens place of 2, and a tens place of 3. Imagine we didn't have any numbers in the 20s. These 3 20s were all gone. You would still put a 2 right here, and then there would just be no leaves on it. It's very important for all of our graphs, just like on the dot plot, on the bar graph, everything is labeled very consistent scale-wise. So these are all one number apart from each other. Okay, it's important that this is all to scale. We wouldn't skip a number here just because it didn't have anything on the right. We would still put the tens place on the left, and then it would just have no ones places on the right. All right, and now we need to go least to greatest. So we got 2, and then 3, and then 3. And because we've left a single digit on the right-hand side, you don't have to use commas. As mathematicians, we want to write as little as possible. So I'm going to pause my video, you pause yours, and we'll catch up when we've finished with the stem plot. Well, I don't know what I just recorded, so we'll see at the end. But I wanted to check in and say that the 0 and 1 that I've underlined, the first 0, that stands for 10, and the 1 that I've underlined stands for 11. So that's how you do the 2-digit numbers. And now we have finished our stem plot. So there are only 4 lines here, so it's not a great graph to see the shape, center, spread, and those kinds of things that we're going to be interested in. So at the end here, we're going to use the same data and split the stems, so I'll show you how to do that. But for now, what percent of the students in the class have 10 or more pairs of shoes? So we need to count how many have 10 or more. So I'm getting 15. And then I just double checked. We had 15 in the 0 and 15 in the other, so that's good. So 15 out of the total, which was 30. So percent, that comes out to 0.5, which is 50%. Describe the shape. We haven't really gone over shape yet, but what you would do is I physically turn my paper so that the stem is in order from least to greatest. So I will turn it actually. Here we go. And then I grab another color and then I go like that. The tail, because I've turned my paper, the tail is going to the right. So this is skewed right. Other options would be skewed left or symmetrical. And right now we're going to write, I don't think there are any outliers here. It doesn't seem like there's a single number over here that's super far away from the rest. And we'll develop an actual rule when we get to 2.5 for outliers. But for now, if there was something very far away from the rest of the numbers, that would be an outlier. So there do not appear to be any. Once we've learned how to calculate them, this would not be an okay response. You would need to actually calculate it. Okay, try splitting the stems in 2. Here's how we do that. Number of pairs of shoes. I forgot something really important. The key. Go back up to number 3, the key. I like to just pick a random number here, and maybe even one that we don't have, like 13. 13 would be represented by 1 big line, 3. That would equal 13 pairs of shoes. The key is important. You got to have that if you've got a stem plot, because otherwise that could mean 1.3 if we're talking about like how many grams a bag of chips weighs. I don't know anything about weight of bags of chips, but anyway, you could talk about it could also be 130. So depending on how many significant digits there were, you would change the key. Okay, now we can move on. Sorry. What? We're going to split the stems into 2. So we're going to actually have 2 rows now for each of our stems. I'm going to come over here to the right so that I have more room. Wow, this is not working. 0, 0, 1, 1, 2, 2, 3, 3. even if we're not going to have any leaves over on the side, we still need to put the same consistent scale. Now, anything 0 through 4 goes on the top line, 5 through 9 goes on the bottom line. So we've got 0 on the top line is going to get 2, 3, 3, 3, 3, 4, 4, 4. And you try to line these digits up so that they are very consistent. A 1 doesn't take up as much space as a 3, but you should still make it take up as much space here. Now at 5, start our next line. 5, 5, 5, 8, 8, 8, 9. Then we can start our 10 through 14. So 10, 10, 1, 2, 2, 4, 5, 7, 7. We have a 20. We have a 25 and 27. This is so tiny. And a 30 and a 38. There you go. Now it's a little easier and a little more obvious to see the shape of our distribution here. Okay, last thing here is that we need a key again. So key, I'll just do the same one. 1 line 3 equals 13 pairs of shoes. Units are important as well. All right, that is it for stem plots. You can use this box to write down all of those little tidbits that I talked about. Don't forget this. And then we'll do the check your understanding in class. One more thing that we had wanted to talk to y'all about. So the other kind of stem plot you might see or might encounter is a back-to-back stem plot. So here's an example of that. You go from the center outward. So where you went least to greatest on the right side, you're still going least to greatest, but it's inside out. Okay? When you have to talk about center, shape, spread, and that sort of thing, you're still going to turn your paper. And your stem should be in order least to greatest. And you don't have to turn it the other way for the other side. It's always least to greatest. And then you can see really clearly your back-to-back stem plot to compare two different samples. Now I'm right side up. All right, have a good day.